Hi everyone, in this video we are going to learn more about the Doppler effect. The Doppler effect is the change in frequency of any kind of sound or light wave produced by a moving source with respect to an observer. So what that means is that if one object is moving away or towards another object, you might see a change in the frequency of the sound or light waves of that object that is moving away from the other object. Think about an ambulance driving by you going very fast. Say you're stationary on the street. The pitch of the siren, the sound waves, change as the ambulance approaches you and passes by you. This is because the sound wave's frequency is increased as the ambulance approaches you or gets closer to you, and it decreases and the wavelength becomes longer as the ambulance drives away from you. When Edwin Hubble studied the universe, he realized that a similar phenomenon occurred with the light created by stars. So again, we can think about the Doppler effect as an ambulance driving by. If the ambulance is moving away from you, the sound of the siren changes pitch. It kind of drags out more because the frequency of the wavelengths is getting longer. But as the ambulance approaches you, the pitch changes. It gets much higher as the frequency of the wavelengths gets kind of squished together as the ambulance is racing towards you. Recall or remember that blue visible light has a short wavelength and high frequency, and red visible light has a long wavelength and low frequency. This is relevant because Edwin Hubble discovered that if an object is moving toward Earth, its light shows a blue shift. But if an object is moving away from Earth, its light shows a red shift. A blue shift is when objects that are moving toward Earth release light that appears to have a shorter wavelength. The light is shifted to the blue end of the spectrum because the wavelength is kind of squeezed together. Blue light has a shorter wavelength, so when it gets squeezed together, it shows more of a blue shift in its spectrum. Red shift is when objects that are moving away from Earth release light that appears to have a longer wavelength. This light is shifted to the red end of the spectrum because as the object is moving away, the wavelength is getting stretched out as the object moves away. Okay, so let's go ahead and fill in this chart. We are going to compare redshift and blue shift. Let's start with redshift. If you see a redshift, that means the light is moving away from Earth. And in a redshift, the wavelength gets longer. The way that I remember redshift is by thinking of the rhyme red ahead. I also remember redshift by thinking about the lights on a car. If you think about the lights on a car, the red lights on a car are on the back of a car. It's the brake lights. So if you see the red brake lights on a car, that means the car is moving away from you. You're looking at the back of the car and it's moving away. Let's compare this with a blue shift. In a blue shift, the light is moving toward Earth. And here the wavelength is getting shorter. The way that I remember this is by thinking of the rhyme blue to you If you see blue, it's moving to you, toward you. And again, we can think of a car. If you think about the headlights on a car, some of those new fancy cars have bluish tinted headlights. And if you're looking at the headlights on the front of the car, well, that must mean the car is moving toward you. So how does this relate to the universe and Edwin Hubble's study of the universe? Well, Hubble discovered that the light that reached Earth from distant stars and galaxies are shifted toward the red end of the spectrum. So since they are shifted toward that red end, their light must be moving away from Earth. And if all of the stars and galaxies in the universe show this red shift, well, that's proof that the stars are moving away from us, which is proof that the universe is expanding or getting bigger.